Hey guys, we are on Unit 4. This is day 1, and it's called shifting functions. And if you guys remember from geometry, a shift of a graph is called a translation. All right. It says the basic geometric transformations of translating or shifting, reflecting, which is flipping, or rotating, which is turning, and dilating can be all done to the graphs of functions by algebraically manipulating them. We will be doing the translating or shifting. We'll do reflecting, but we will not be rotating or dilating them. Okay, so we just got basically 2 days out of the 4 days that we're going to talk about in this unit based on our year so far. Okay, so number 1 says consider the functions. F of x equals the absolute value of x. G of x is equal to the absolute value of x minus 3 plus 2. And h of x is equal to the absolute value of x plus 1 minus 4. And they want us to identify the key point of f of x. Now, f of x is already graphed. And so the key point, since it does look like a V shape, in fact, all absolute value graphs look like a V shape, which I think is funny for absolute value, V for value. But this right here, where it turns, or its turning point, would most likely be our key point on f of x. And so this point right here has coordinates of 0, 0. Okay, part B says graph and label g of x and h of x on the axes provided. So you guys are going to need your calculators. Okay. We're going to go to y equals, and we're going to do g of x first. Okay, so g of x has this equation here. We're going to go to y equals. In order to get the absolute value, remember, hit second 0 to get to your catalog. And ABS is the very first thing that shows up. And so we're going to hit enter. It'll take you back to y equals, and you're going to type in x minus 3 inside the absolute value, and then arrow over and hit plus 2. Okay. We're just going to make a small table of values for g of x. Okay. We have an x and a y. Our table is going to kind of go horizontally instead of vertically like normal. But we're going to go ahead and graph. Looks like a nice group number that'll fit on our graph would be coordinates of 1, 4, 2, 3, 3, 2, 4, 3, and 5, 4. We'll graph that and see if that gives us a nice graph. So 1, 2, 3, 4, 4, 2, 3, 3, 2, 4, 3, and 5, 4. Okay. If I had a nice straight edge, I would use it. I'm going to try to draw the best straight line possible. Okay. And there is g of x, and we're going to make sure we label it. And then we have h of x to do. So I'll do h of x in green. We're going to go back to y equals, okay, and just change a couple things. Change the negative 3 to a plus 1. Change the plus 2 to a minus 4. And then go ahead, and if you want to hit graph, you can look at the picture. But again, it's going to be a V shape. More importantly, we need that table of values so we can get those coordinates on my graph so I can make a nice picture. All right, so it looks like, looking at our table, negative 3, negative 2 we're going to use, negative 2, negative 3, negative 1, negative 4, 0, negative 3. I'm going to squeeze one more in there. We're going to do 1, negative 2. All right, so let's go graph them. Negative 3, negative 2, negative 2, negative 3, negative 1, negative 4, 0, negative 3, and 1, negative 2. Okay, nice straight line to connect our points on the one side and the other side, and a nice label. Okay, we'll call this one h of x. All right, so part A is done, part B is done, part C. Okay? It says, what were the key points on g of x and h of x, and what did these key points describe about the graphs? So on g of x, our key point was our vertex, which is now located at 3, 2. This is our vertex, or our turning point. Okay? On h of x, our vertex is now located down here, and so that's coordinates of -1, -4. And some of you might be seeing a little bit of a connection to the numbers in here for h of x and the numbers in here for the g of x. And those numbers actually do have a relationship with where the vertex went to. All right. So if we take a look at g of x, this graph, remember I told you guys we were translating, it slid 1, 2, 3 units to the right. And then it slid 1, 2 units up. Okay. And so you can see in our equation a -3 and a +2, but when we go to the right, that's a positive direction. And when we go up, that's also a positive direction. And so what we're going to learn is that anytime you're grouped with x, okay, when a number is grouped with x, the sign on of it is going to be the opposite of what you will think. Okay, so the sign is opposite of what you would think. All right, so if I said 3 units right, I'm thinking +3. However, you're going to see that it's grouped with x, and so it's going to be a -3. Okay, and then the 2 up is going to be on the outside there, but it's not grouped with x, and so it's the same as what you think. Okay, why is the 3 grouped with the x and not the 2? Well, remember that going to the right or to the left is what we call x movement. Okay, up and down is our y movement. So anytime you go to the left or the right, remember that it's the opposite of what you would think. Okay, so let's see if it works with the h of x one. So if we look at h of x and we go back to our original, okay, which is here in the middle at the origin, this one went to the left one. So one left. And then it went down 1, 2, 3, 4. So 4 down. Okay. So when we say to the left, I would think that that is subtraction. Okay? And 4 down, I would also think is subtraction. Okay? But based on what we read here, number is grouped with x, the sign is opposite of what you would think. That one left and right, it gets grouped with the x's, that's x movement. This, I guarantee when we look up there, is going to be a +1, and the 4 down is going to stay a negative. Okay, so let's take a look. Yep, there it is. There's the +1, and there's the -4. All right, so a little bit tricky. Be cool if x, did what we thought, but that number grouped with x, it doesn't do what we think. It does the opposite, and so that's something we have to remember. Okay. Part D says, how would the graph y equals absolute value of x, and that's what they call a parent function. Okay, it's what you're starting off with. Be shifted in order to produce the graph of y equals absolute value of x minus 6 minus 8. Okay. So let's take a look. We have two numbers in there. First off, this -6 is grouped with the x. With that -6 being grouped in with the x, we know that the 6 is our x movement, okay? And so we're going to go 6 units or slide 6 units. Okay? Now, that -6 makes me think to the left. However, based on what we talked about, it's not. It's going to be 6 units to the right. Okay? All right, so what else do we have in here? We have this -8 tacked onto the end. See how it's not grouped with the x? It's not in the absolute values with it. Okay? And so we're going to go 8 units. Oops. 8 units. And this does the same as what you'd think. So that -8 right there makes me think 8 units down. This one is going to be 8 units down. Okay? It's only the one grouped with x that's the opposite of what you would think. Okay? Cool thing is you have a graphing calculator and you could put that in y equals and you could test to see if it moves 6 units to the right and 8 units down. All right? Okay. All right. So on the bottom here, talks about vertical and horizontal shifting. Okay? And the tricky one is the horizontal. And it's not so much that it's tricky, okay? It just does the opposite of what you would think. So you see a plus k grouped in there. That plus makes you want to say that it's going to the right. But it's not. It's going to the left, okay? This minus in here makes you think to the left. Okay? Again, it's grouped with x, so it's either going to be left or right, okay? But it's the group with x, so it's going to do the opposite of what you think, okay? So opposite of what you would think. So positive actually means left, negative actually means right, okay? If you're grouped with x, the x is affected. All right, so going back up, with vertical, notice that plus k is not grouped with the x. It's going to do the same as what you would think. So that plus sign, I would think up, and it is. Okay? That minus sign, I would think down, since you're not grouped with the x, and it is. Okay? So it's the same as what you would think. Positive means up, minus means down. Okay? And notice that it's not grouped with the x, so that's the y being affected. Okay? Whereas if you're grouped with x, your x movement is affected, left and right. All right, so let's try something else. Number 2. In number 2, it says that the function f of x is shown on the grid below. A second function, g, is defined by this. Okay. They want to know what transformations was applied to f of x to get g of x. And so if we look in there, we always try to do the parentheses first. Think about PEMDAS. Okay. And so we're going to go ahead and talk about the -3 first. Okay. And so that -3, I know it means 3 units. So it's a shift. Oops. So it's a shift of 3 units. And now it's grouped with x, right? So I would think that that minus in there means left, okay? But it's not. It's 3 units to the right. All right. This +1 on the end is also going to be a shift. However, this shift is 1 unit. Now, because it's not grouped with the x, the y is being affected, and it's the same as what you think. So if you think +1 means up 1, you are right. So 1 unit up. All right, so then that's the transformations applied to f of x, okay, to get g of x. Now in part B, they want us to graph g of x on the grid. Okay? So all I'm going to do is I'm going to take the important points, for instance, this point here, this point here, this point here, and this point here. You could take more points if you wanted to, but that's the fewest amount of points that you should be able to take. All right, and what we're going to do is we're going to go ahead and shift each one of those 4 points 3 units to the right and 1 unit up. So I'm going to start with this top one, 3 units to the right and 1 unit up will put us right here. Okay, we're going to take the next one down here in quadrant 3, 3 units to the right, 1 unit up will put you here. Then we're going to take the one right below it and go 3 units to the right and 1 unit up. And then we're going to take that red point that's right next to it and go 3 units to the right and 1 unit up. Okay? If we try to connect our dots with nice straight lines, there is our graph of g of x. Okay, so part B is finished. Part C says algebraically find g of 0. They said algebraically, so that means show our math. So we're going to go ahead and say g of 0 equals. So we're going to go to a nice g equation up here. And anytime there's an x, we're going to replace it with a 0. So this is going to stay f. In parentheses, that x minus 3 is going to become a 0 minus 3. Close it up. And then plus 1. Okay? And now we're going to go ahead and clean it up. 0 minus 3 is negative 3. And then plus 1. Okay? Now, f of negative 3, we're going to go to our graph. And f of negative 3, 1, 2, 3. Okay? And in order to go ahead and hit the graph, we would have to go up 1 to this point right here. And since we went up 1, we're going to say that f of negative 3 is equal to 1. And then this plus 1 is going to fall down, and 1 plus 1 is equal to 2. So we're going to go ahead and say g of 0 equals 2. And what that means is that 0, comma 2 should be on our g of x graph. Okay? And 0, 2 is literally right here. And you can see, and you can see even better if I used a straight edge, but it is on there. All right, and so that is what that means. All right, I'll see you guys in a little bit for the backside of notes.